Alright, so today we're doing 2001 AP Calc free response number 6, and if you want to pause the screen and work out the problem, and then you can watch me solve the problem. So, we have these two functions inside this one piecewise function, and the first problem asks us to show that this function is continuous at x equals 0. So what that means is, say I draw some, I think green is good. So say I draw out two functions, or just some random function. One is like this, and it stops at 1, and another one picks up where it ended. And this first function is from x is greater than or less than or equal to 1, and the other one is for x is greater than 1. So when you're trying to prove continuity, you want to prove that the two functions approach the same value at the one point where they meet, right? So here I would say that this is continuous, right? You want continuity means that you can draw the graph in one swoop, right? You don't have to pick up your pen to do something crazy like this where it like drops down. Right? Continuity is one movement, one line. So, for this problem, what we're going to do is we're going to plug in 0 into the first part of the equation and 0 into the second part of the equation and see if those two values are the same. If they are, then f is continuous. If they're not, f is not continuous. So, plug in 0 into the first one and 0 into the second one. So we know that sine of 0 is just 0, and then 2 times 0 is also just 0, so this is 1 minus 0 is 1. And then we have e to the negative 4 times 0, so that's basically just e to the 0, which any number to the 0th power is just 1. And because these two values are equal, f is continuous at x equals 0, right? Cool. And for question B, the question asks to express f prime of x as a piecewise function. So what we do is we take these two parts of the piecewise function and we take the derivative of both of them. So let's do black. So f prime of x equals, let's see if I can draw this a little, it's a little bad, but okay. So the derivative of the above function, we get rid of 1 because that's just a constant, and then the derivative of negative sine is negative cosine, and we keep the 2, so it's negative 2 cosine of x. The derivative of e to the negative 4x is simply just e to the 4x times the derivative of negative 4x, so this would be negative 4 e to the negative 4x, right? And then the second part of the question asks us to find a value of x for which f prime of x equals negative 3. Now when we look at these two equations, we've got which one equals negative 3, right? Well, if we look at the cosine of x part of the derivative, we know that cosine starts up here. The normal cosine graph only has only goes from negative 1 to 1, right? Its amplitude is 1, so it will only reach negative 1, and then negative 1 and 1. And then when we multiply that by negative 2, we know it'll only reach negative 2 and 2. So there's no possible way for negative 2 cosine x to equal negative 3, right? If this had been a negative 3 out front, then there was a possibility. But since it can't possibly equal negative 3, we can get that out, and then we can figure out when negative 4 times e to the negative 4x equals negative 3. So what we do is we just solve for this x. So 4x equals negative 3. So what we do is we divide both sides by negative 4. So these two negatives cancel out, so we get 3/4, right? And then we can take ln of both sides to get rid of this e. So ln of e to the negative 4x equals ln of 3/4. And because we took the ln of this is brought down here, and ln of e is just 1. It just cancels out. So negative 4x equals ln of 3/4. So then we divide by negative 4 to get our x. So we would say that the value for which f prime of x equals negative 3 is ln of 3/4 divided by negative 4. Alright, and then for the last part of this question, it asks us to find the average value of x on the interval from negative 1 to 1. So, first let's write down the average value equation. It's 1 over b minus a times the integral from a to b of f of x dx, right? And since we're given the interval, we can plug in 1 minus negative 1 from negative 1 to 1 f of x dx, right? And we can, what we're going to have to do is we're going to have to break this integral up into two integrals, one from negative 1 to 0 and the other from 0 to 1. And the reason for that is because if you look at this piecewise function, 1 minus 2 sine x is for x is less than or equal to 0, and then e to the negative 4x is for x is greater than 0. So because you have two different functions that have different domains, you're going to want to split it up, right? And you know you can do this. It's one of the integral rules. So our first one, from negative 1 to 0, is 1 minus 2 sine x dx. The other one is from 0 plus 0 to 1 e to the negative 4x dx. And all of this is multiplied by 1/2, right? So, I guess I'll start integrating. I'll probably run out of space though. With this 1/2, I normally just write it up in the corner and then I just forget about it. But I don't forget about it. I just disregard it, I suppose. I integrate everything first, and then I take the final product and I divide it by 2. It's just easier that way for me. So we'll just erase it. Our 1/2 is up there. So let's start integrating. So 1 antiderivative, that's x, and then the antiderivative of negative 2 sine x is positive 2 cosine x. And we know that because cosine flips the sign whenever it derives. So this is from negative 1 to 0, and then the antiderivative of e to the negative 4x is just e to the negative 4x over negative 4, and this is from negative 1 to 0, right? I don't know if I'm going to have space up here. I'll try it. So now we just plug stuff in. So 0 plus 2 cosine 0 minus negative 1 plus 2 cosine of negative 1. All of this plus e to the negative 4 times 0 all over negative 4 minus e to the negative 4 times negative 1 all over negative 4. I just realized I set up this this incorrectly. My goodness. Alright. Rewind. Plus e to the negative 4 times 1 all over negative 4 minus e to the negative 4 times 0 all over negative 4. Right? And I find these brackets sort of like an easy way to deal with negatives and positives and stuff, but I tend to just add stuff here together and add stuff here together, and then take the two sums that I got and add those together, right? Just a easier way for me to see it. Alright. Now, let's take it up here. So 0 plus 2 times cosine of 0. Cosine of 0 is 1, so we know that this is 2. Then it's negative, it's minus a negative, so it's now positive, so plus 1. And then it's minus 2 cosine of negative 1. And because we don't know what cosine of negative 1 is, I'm just going to leave it that way, because you don't always have to simplify your answer to the most simple way. Because if you don't know what cosine of negative 1 is, you're not going to waste your time trying to figure that out, right? Just leave it that way. Then we've got a positive and a negative, so that means that this is going to be a minus e to the negative 4 over 4, alright? And then we've got a minus and a minus, so this is going to be plus e to the negative 4 times 0, that's just e to the 0th power, so plus 1/4, right? And now let's just clean this up a little. 3 negative 1 minus e to the negative 4 over 4 plus 1/4, right? Just added these two together. Now we can rewrite 3 as 12/4, so that we can add these two terms together. So we get 13/4 minus 2 cosine of negative 1 minus e to the negative 4 over 4. And then you might think that you're done, but remember our 1/2 up here. We have to multiply all of this by 1/2, and then that will be our average value, right? So 13 over 4th times a 4th is just 13/18, and then this negative 2 goes away once you divide it by 2, so minus cosine of negative 1, and then this becomes negative e to the negative 4th over 8, right? And that, whoa, extended out a little too far. And this is the average value of f on the interval -1 to 1. So you can see how the math can get a little complicated when you're integrating without a calculator, but like even I made a couple mistakes here. So it's always important to do this diligently. Do not speed through it, or else you'll end up with the wrong answer. And that's no good. Ooh, it's the end screen. Click on one of these links to be directed to that playlist. And don't forget to subscribe!